All right, so now let's look at neutralization reactions. And neutralization reactions are when we're mixing usually a strong acid with a strong base. And you need to remember the general word equation for it is acid plus base goes to salt and water. So that's our general word equation for neutralization. We take something that's acidic with a low pH, we take something that's basic which has a high pH, we mix them together and we end up with something that's neutral or a pH close to 7. But the products of that are salt and water. So the reactants, acid and base, products are salt and water. Now if we look at our neutralization sheet here, let's do the first couple, hydrochloric acid and sodium hydroxide. So we need to know the formulas for those two reactants there, the hydrochloric acid and the sodium hydroxide. So hydrochloric acid, if we look at our sheet here, we know that hydrochloric acid is hydrogen and chlorine rather. So HCl is our hydrochloric acid. And then our sodium hydroxide, sodium from our sheets, Na with a 1+. And then hydroxide is actually on our anions and cations sheet. So hydroxide, OH-. So we've got the 1+ for sodium and the 1- for hydroxide. So we know that there is already balanced. We don't need to do anything else to that one. So we're mixing hydrochloric acid with sodium hydroxide, and it's going to give us a salt and water. So let's start with water, because we know the formula for water is H2O. So we've taken this H, that H, and that O to give us H2O, which leaves then the sodium and the chloride or chlorine atom, NaCl. Now, I'm pretty sure that's balanced, but let's just double check. Sodium is 1+, chlorine is 1-, so we know that this part's balanced. And H2O, we know that hydrogen is 1+, oxygen is 2-. We have 2 hydrogen pluses and a 2- for oxygen. We know that that's balanced. So that's the answer for our first neutralization reaction. Now, let's look at the next one, sulfuric acid and calcium hydroxide.